Hi. Yeah, my name is Dennis. I'm a web solutions engineer at Geolitics. At Geolitics is our Twitter handle. Would be really happy if you find out more about the company who affords me to come here and what we do. And also I'm a poodle dad and have a dog's Twitter account which I manage, and Geolitics would be happy if they can catch up with the viewers my dog gets. I'm also a geographer, not the social kind, meaning I studied physical geography. I don't really do that anymore. I'm just working on the computer. Hardly do any geography these days, but I'm still very much concerned about our geography. Please come in. Well, yeah, my own Twitter handle, Bauszus, at Geolitics. So what's Geolitics? We are a location intelligence company. So we actually do mostly social geography. We consultant for retailers, franchises, where to put the store. So in order to do this, we have a couple of very smart people, mostly data scientists, and a lot of data. And I write the interface for our findings to communicate information to our clients. So make better decisions where location matters is our mantra, as you can find on our website. So what do I do? What does a web cloud solutions engineer do? Well, I code as it is, because I believe in no code, and I promise you there will be no code in this presentation, because there was already a lot of code for coding yesterday in my workshop. So on a good day, I write maybe 10 lines of code, so that's not actually a lot of coding. On a very good day, I delete 10 lines of code. That's the best day. So what do I do all the other time? Well, I don't code. Well, I worry. Mostly I worry. Worry about performance. Worry about security. Security is paramount for everything we do, because an application can crash. That happens. Algorithms crash. That's not a disaster, but if you have a security breach, that could be it for the company, for the career. So yeah, worry about my career as well. Worry about usability, not just about the client's usability, but also our developers' usability. All the code I'm doing is open source, so do people use it? Will they use it in the future? I mean, there's tons of stuff to worry about. Always looking about my shoulder. It's so many other brilliant applications here, and it's not just location analytics, but like web solutions. There's a shake a tree, another web solution falls out. It's just so much on the market. But if the grass is green on the other side, you can bet the water bill is higher. Well, what does it mean? Well, a lot of other solutions are really, really good because they put a lot of money in it. There's a lot of people there. They have good hardware, good infrastructure. You can't do it all alone. Whether it's documentation, whether it's design, whether it's performance, all of these things I worry about. I look at what other people are doing. I mean, that's why we're here. Like, we want to learn about solutions from other people, and that's where I work. It's graphic, but I work at home. I hardly ever go to the office, and it's massive benefits. There are massive environmental benefits. Mainly, you can work at home. You generate solar energy on your roof, and you're working environmentally friendly. Like, you have a zero carbon output, and a lot of us do it, and that's, in my opinion, a part why the cloud is so successful, because we don't want to have our data on our computers or in our office. We want to have it in the cloud. We want to have access wherever we are, whenever we are. Hence, Balkonkraftwerke. That's it's a German expression. It's basically if you have the solar panel and your counter goes backwards, so you can also work at night and use the electricity for the same price. It's not legal though. BBC Panorama had recently a program, Is the Cloud Damaging the Planet? I found that was a really excellent program, and the main point is data size. There's just so much data of it. We keep everything. Myself, I looked at my Google profile the other day, and it was like 10 gigabyte of stuff I don't need that stuff anymore. So, but I don't want to delete it all, and I can't go through all of it and go, yeah, I need this, I don't need this, and I delete it. It's just so much backup. Everything has a backup. Even backups have backups. It just piles up. So what's the elephant in the room? Well, the elephant in the room is the Postgres elephant, and the problem is like all that data which accumulates has to be stored somewhere and has a negative effect on the environment. And why is that? I mean, Postgres is not the problem. Like we are the problem. How we're using it? Why we use Postgres? Because it's so good. It's so easy. So talking about backups, how do we make backups of Postgres? Well, we create another Postgres server. We create another Postgres database. So are they running all the time? Yeah, maybe they're running all the time. Should they be? Well, let's discuss this. It's a lot of geometry. Like we have a table with OAs or postcodes, and they have information. And then we have a different table with different information but the same geometries. And we might end up like on a different server in a different region, and we have the same geometry. So there might be one geometry, optimized, not optimized, maybe multiple versions of it, and we have the same geometry hundreds of times, just associated with different information. So we should look at this. If there's one geometry, then we should only keep one form of geometry, ideally the optimized version, and then the other information we just associate with the geometry when we need it. So it's a lot of geography. It's active geo-replication. Like we have clients in China, we have clients in the US. Sometimes the same client has a different position. Do they need the active geo-replication? Do we need the data in China, Australia, and the USA at the same time? Or is it okay if I access the data and it's get cached in the edge? Maybe it takes a little bit longer. But I mean, what's 3 seconds? What's 4 seconds? It's not the end of the world. Unlike climate change, which is quite literally the end of the world. So yeah. Caching strategies, we heard about that earlier. Do we need to cache everything? Do we need to? You ain't gonna need it. Like maybe if you zoom very far in, you don't need to cache for that. We can create that data on the fly. The top one, yeah, we definitely should cache that, because you open the application, your web page, your map, and everybody sees the same tile at the beginning. So definitely, that should always be cached. When data changes, do we immediately have to cache it again? Do we store all the cache? Do we store it indefinitely? I mean, that's all questions which not just concern performance and usability, but also the environment. And yeah, don't just throw money at it. So that's back in the day, we run out of space, we throw money at it. We don't delete old stuff now. We just buy a new hard drive or buy a new server. Like anything can be solved with money. Employ people who maintain the database. It's the easiest way. Just making money. That's the difficult part. It's not always the fastest who wins. Like as I said, 3 seconds. That's not a disaster. Same as performance. Like maybe the application is not the fastest application. Maybe not the best looking application, and still people use it. Hopefully they do. Because it's got to be smart caching. We need to get a good package. We need to think about all the things associated with the work we do, and hopefully our clients feel the same way and make a decision that we want to work with you, not because it's the best, but maybe because there are other concerns. See, database always on. How do you scale? So that's worry of mine. Like how we go from 10 to 100 users, how we go from 100 to 1,000 users. Like you can't really think like this. You just need to think how we do end users. Like the scaling, it shouldn't be. You don't want to have a database always on, but you want to scale it. So users come and. Processing computing units are scaled up, and I need more space, and then the space is scaled up. I don't want to have like a server running with a terabyte or petabyte hard drive, but I still have hard drives and it's mostly empty. It still uses electricity. This is serverless Postgres, really love it. I love Neon. It's not fast, but it's great. It's great usability, very easy to use, just it's free. You start with free, but you're in the back of the load balance queue. Basically works like this. The people who pay for it, They say how many computational units they use, and the people who don't pay for it, who are in the feature preview on the hobby accounts, they use the computational units you pay for but you don't use. So that's sharing computational units, processing, and also storage. It's a great way forward. So yeah, we love it. Oh yeah, as I said in the notes, you might have read about Bit.io, and why I'm not talking about Bit.io. Bit.io got bought by Databricks. I heard about this on a week ago, 2 weeks ago, so then I had to move from Bit.io to Neon Tech, which is basically the same product, which is probably the reason why Databricks stopped using that, or also because maybe they thought there are better alternatives. So what are alternatives? Well, formats, there are different formats. Not everything needs to be vector tiles, so that's mainly we use vector tiles. It's quite easy to generate vector tiles with Postgres, but if you have raster data, now obviously that's not an option to use vector tiles, but the issues are the same. And but what's our options? Our options is a points layer. So for example, if you have a point layer, don't necessarily use vector tiles, don't cache it, like use aggregation, like you go in and instead of multiple tiles you're requesting, which are multiple requests, which have to be processed multiple times and multiple tiles have to be cached. So it's a lot of computation. Just do one query, like one query for an aggregation of points at your viewport and display it. For example, WebGL and open layers, fantastic technology. Alternative storage formats. So on our relational database, Postgres, but we have file databases. Well, it's not a database, a file storage. So don't use a shapefile, please. Also, file storage might be a misnomer because lots of us think about S3 as a file storage base, while indeed it's a block storage. You upload a file, but then the file is stored in blocks or object storage, like MongoDB, quite popular. Benefit for these, especially like S3, is the separation of the computational units and the actual storage. So that's great. Well, sorry, where are we on time? We've got plenty? 8 minutes, okay, fine. Yeah, so there's actually not that much to go. As I said, a BigQuery. So that is one thing. You pay for it and you have like one query and also BigQuery. What's BigQuery? How does it work? Is it a block storage? Is it an object storage? I don't actually really know what it is, but if I just, before this talk, I checked BigQuery, how does it work under the hand, and they said, well, the same things, durability, usability, performance, security, and the main thing what they said on top is separation of computational units and storage, the data at rest where it is, and that's how it works. So multiple requests, well, one request is split into multiple requests going to different computational units which work all at the same time, but they share the same storage, and that can be one person or multiple person accessing the same data at the same time, and they access the data just where they need it. So same principle is it's GeoPacket. It's this new format, many of you know it. It's basically packet which can do geo. So it could be a file. It's like you don't need a database. It's a file, can be a GeoPacket file, and it's a column storage. So again, you access what you need. So could put the file and block storage and say, okay, I only want the data in my viewport, and it queries the data, uses the indexing. It's fast. It's not as fast as Postgres, but it's good. It's necessary fast enough. Like it won't hurt you waiting. And who's involved in that? But it's big companies. Like everybody is involved in it these days. Like literally everybody. Wish could put our name on there. But I also wanted to talk more about GeoPacket, but just didn't have the time to. Then at the time to write an adapter plugin in our framework to use GeoPacket. So I know about it, but I don't use it. So maybe I should in the future. But main thing what we see here, they're not charitable organizations. Like if you go to them, you gotta have to give them money, and which is pretty much my last point. What's a good environmental metric? money. That's a good environmental metric. Because you pay for something. You pay either for men or women or metal. Like a server, a computational unit. That's not magic. That's somewhere. Serverless is still a server which runs somewhere, which takes electricity, which takes water, and that's what you pay for. So, and it's a hard market, as I said. Databricks, there are different solutions which offer the same. So, where do you decide to go? Well, don't ask them which is the most environmental friendly company. No, you go to the cheapest. Like, we put the less money, and said they don't use the magic. So, what? They're using their money for. Using their money for metal, actual metal dug up out in the earth and processed into machines and water. I mean, used to create the machines and running them and electricity. So it's so that's all summed up here. Water and electricity. Why? Why? Because it's very expensive to heat pools, like and data centers use a lot of water. Like in that BBC Panorama report, which circles us back to the beginning, is a new data center gets on average an allowance of more than 1 billion liters a year. Now, obviously, 1 billion is a mind-boggling big number. That's enough to fill an Olympic-sized pool every day. And coming to my last slide, when putting that thought forward, it's what's the best solution? Again, from the BBC was an article about Deep Green, which runs tiny data centers and uses not the water you swim in from the pool. Now they're using an oil, and the oil is used to heat the pool. So if you like to swim in the winter and you like the balmy water like me, then that's a fantastic idea. Like, you have the data center, and you have nice warm water, and it's climate and society friendly way to compute. And just, yeah, I want to end on this because I think that's one of the best ideas. Like if they open a data center in my local London Field swimming pool, yeah, but I go more often swimming, pools don't have to close down, and I would give them money so that we can store our data locally and environmentally friendly. Thank you very much. That's my talk.